Hi everyone, how are you? My name is Praveen Sahu. I'm a mathematics JEE faculty. I have been teaching mathematics for grade 11th and 12th as well as JEE aspirants. So in this session we are going to discuss about determinants. Especially we'll take the topic Cramer's rule. Cramer's rule is a very effective, very important for the board point of view, also for the JEE purpose also. It helps us to solve simultaneous linear equations in three variables. Today we are going to discuss that topic. So are you ready guys? Okay, let's see. As you can see here on the board, we are going to discuss about the Cramer's rule, and Cramer's rule talks about how we solve particularly a system of equation here. So x will be equal to del x upon del, and value of y variable will be equal to del y upon del, and z will be equal to del z upon del. Now the question arises, what are these dels? Basically these dels are determinant. What kind of the determinant they are? First of all, del, we can see here there are three simultaneous equations in three variables. Now del is equal to, it's just a coefficient determinant, and in del 1 we will replace column 1 with the constant numbers. In del 2 we'll replace column number 2 with the constant numbers, and in del 3 we'll replace all the third column with the constant numbers. Now here one of the application we are going to discuss about. First of all, we have given a equation system of linear equations in three variable here. Now we are going to solve this particular system of equation. That means we are going to determine the x, y and z value. So we'll first of all, the first step is here, step number 1. Now let's solve this particular question. Here in this particular question we'll also try to find just similar as the theory. Like first of all we'll find determinant. What is determinant here? Del will be all the coefficient numbers, determinant of the coefficient, that is 1, 2, 2, then 1, 5, 1, then 1, 7 and minus 1. Now let's expand this. You know how very well how to expand such kind of the determinant. Always we use like this will be positive, negative and positive kind of thing. So 1 into like 5 into 7, then 1 into minus 1, then negative 1. Again the remaining determinant is 2, 7, then 2 minus 1, and the last one is plus 1. So I am just showing you how to expand 3 cross 3 determinant here. This will become 2, 5, then 2, 1. Now just do cross multiplication. You already know how to open the determinant, but it's just a quick revision. So okay, this is now same, 2 into 1 is 2 minus 10. Okay, what we are getting here, del is equal to, this is obviously minus 12, and this is positive 16, and here we are getting is minus 8, correct. So del is minus 20 plus 16, which is obviously minus 4, and here we get del is equal to minus 4. Now dear children, this is a task for you, how you will determine del x, del y and del z. I'll just give you one hint that how we'll write del x. So in the same determinant, I'm erasing this. In the same determinant, we'll replace the column 1 with the constant number. So this is the column 1, this is the column 1, and we'll replace the constant number with the column 1. So here I am writing 9, 52 and then 0, correct. Sign will be same like plus minus plus, you have to expand with respect to R1. This is a task for you, and you have to determine the value of del x, del y and del z. Quick. Okay, done. So just check with your answers whether it's correct or not. Del x, del y and del z. Okay. After getting these answers, what we will do, we'll simply follow the Cramer's rule here. And what is the Cramer rule exactly? X will be del x upon del. So what is del x here? This is minus 4 upon minus 4, which is equal to 1. So simple. Just like y, how we'll find value of y? Del y upon del, that is equal to minus 12 upon minus 4, which is 3 here. And how you will find z? It's a task for you. Just determine the value of z. So the final answer will be x is equal to 1, y is equal to 3. Just pause the video and calculate value of z. Done. So z you will get that is equal to 5 here, because 4 5s are 20. Now you can satisfy these values also. Let's say in equation 1, just put these values. 1 plus 3 plus 5, which gives you 9. Similarly, you can check the rest of the equations, right? Okay, children, now let's solve the next question. This particular question belongs to JEE Mains level. So let's read the question first of all. Here the question says that N denote, capital N denote the number that turns up when a fair die is rolled. So the first line of the sentence, what it says, that N denotes the number that turns up when a fair die is rolled. So obviously N is the N 1, 2, 3, 4, 5 and 6. Okay. When we roll a die, we'll get obviously this possible numbers. So this is the first line of the question. Now the second line of the question talks about if the probability that system of the equation, if this system has a unique solution. So here we'll discuss about the nature of the equation. If it has a unique solution, then definitely del will not equal to 0. That means this is our second clue, and the probability is given is k by 6. So let's solve up to this stage of the question. So what will be del here? It's very clear. Del is the determinant of the coefficient. If the coefficient numbers are like column wise I am writing. So 1, 2, 3 coefficient of x, y, z we have to take. So the 1, then capital N, then 3. Similarly, last column will be 1, 2 and then n. Now students, let's expand this particular determinant. After expansion, so we can write like 1 into, I am just opening it directly because already you know that how to expand determinants, practice lots also. So here I am writing n square minus 6, then plus 1, no sorry, minus 1, and then it will give us 2n minus 6 and then plus 1, that will give us 6 minus 3n. Now this implies this is like n square minus 6 minus 2n plus 6 and then minus 3n. This is the value of del here, right? So n square and then this plus 6 minus 6 will cancel each out, then we'll get minus 5 and finally plus 6. Since del is not equal to 0 because the system has unique solution, that's why this particular expression n square minus 5n plus 6 also not equal to 0. But when we factorize this particular quadratic, we will get n minus 2, n minus 3, which is not equal to 0. This means n is not possible 2 and 3. That means this value 2 and 3 we have to remove. Now the possible values of n are, this means the all possible values of n are 1, 4, 5 and 6 only. But the question says that the probability of those numbers is k by 6. It's very clear that probability will be 4 by 6, but which is equal to k by 6 here. This means k will be 4 here, which is matching with our answer. K is equal to 4. Correct. Now the next task for you is the next line. Then the sum of the values of k and all possible values of n is what? So guys, you have to think what will be the final answer of this question. Take a minute, okay, and think about it. What will be the final answer? Done? Okay. Now what's the sum of the all possible values of n? Obviously 1 plus 4 plus 5 plus 6. How much it will give us? It will give us 16, and 16 plus 4, your final answer will be definitely 20, which is here s is equal to 20. Thank you so much. Now this was about our Cramer's rule, which gave us an idea that how we solve system of linear equations in 3 variables. Correct. Now what we have learned from this particular session, we learned that how to expand determinant, obviously we know that, and then how to use Cramer's rule. What are the formula for the Cramer's rule? X is equal to del x by del, y is equal to del y by del, and z will be del z by del. And how to check with the unique solution? For the condition for the unique solution will be del cannot be equal to 0. So this was the summary of the entire session. I hope you enjoyed this lecture or this session. If you have any doubt, you can reach out to me. Thank you so much.